Hi, I'm Jacob Collins. I'm the team lead for the GeoBarista Capstone project sponsored by OG Systems here in Portland, Oregon. My other team members were Tim, Mike, Khoi, Jomar, Shayan, and Trevor. Our team was tasked with replacing an old .NET application that OG Systems has been using to process and handle imagery from their Pearl sensor collections. The problem with the current software is that it has not aged well, and most of the features are never used. The team built a new desktop application to align with the current user workflows. We used Electron, which is a framework that easily allows you to build cross-platform desktop applications using JavaScript, HTML, and CSS. We also use some other common web frameworks such as React, but those will be covered in more detail in a later slide. GeoBarista handles simple yet common workflows such as viewing, sorting, filtering, converting, and organizing images. Next, I will let Trevor take over with a quick demo before we go over the technical details for GeoBarista and how it was created.
Hi, my name is Trevor Hensel. Today I'll be doing a quick demonstration of GeoBarista for you. I'll start by loading our distributable, and we'll be greeted by a world map and a couple menu options in top left and top right. Right now I'm going to focus on this left menu, and I'm going to focus on this load image button as that allows me to load a directory, or in this case a mission. Cut this. Alright, and that's been loaded, and we can confirm that by going to our image menu on the top right, and as you can see the relevant files have been loaded. So I'll click this zoom to button in order to zoom to a selected mission, and as you can see the 2D footprint has been overlaid on top of the map of all the images in this mission. To demonstrate some more advanced features, I'm going to hit this addition icon in order to load another mission, in this case the Grand Hyatt mission, and that's going to load really quickly. Alright, perfect. And in order to demonstrate some filters, for example, let's say we're no longer interested in this Alcatraz mission, we are only interested in the Grand Hyatt, we can sort by mission name, and that puts the Grand Hyatt on top. And we can again hit this magnifying glass to zoom to that mission, and as you can see, again, the 2D footprints have been loaded. So some real world use cases for this are that a user collects a large amount of data around a specific area that they're interested in, and they get a lot of useless data that they don't really care about, or at least aren't interested in at the moment. So in this mission, we have a collection of images and relevant data around a hotel. And this hotel has a pond, so let's just say we are only interested in the pond behind the hotel. What we can do is select our polygon option in the bottom right, and we can actually draw a little polygon over this pond and select all the images that overlay that area. So as you can see, that's represented by the blue being selected and the red being unselected. And again, we can do that, open our image menu, and we can sort by selected. And as you can see, we have 8 or 9 photos selected or so. And this is useful because what we can do now is go to our file manipulation button. And this allows us to select all the files, or if we just wanted thumbnails or say a certain file, because again, a mission is not only just thumbnails or images, it's also all the relevant images or relevant files to that specific image. So I'm interested in all the files, so I'll select that option, and then we can move that to a new directory. So let's just name it pond for simplicity's sake. And now we'll perform a copy. And what that is doing is it's taking all the relevant files to this selection that I just made and copying them to a new directory on the system. And this is useful because now I can load that new directory as another mission called pond, and I can use this different way of filtering and say I just want to focus on this pond. I can hit filter by mission name as well as filter by mission name and then select the mission that I'm interested in and submit that. And now you can see only the 2D footprints of my previous selection or my new mission, because I exported them, are now showing up on the map. And what we can do is select this toggle button right here to display the images, and as you can see, we have a pretty good selection of images that display this pond. Thank you for your time. This was a quick demonstration of GeoBarista.
Hi, my name is Mike Ehart. Outside of general planning on this project, I contribute individually to the front-end development. And right now I'm going to talk to you about our audience. Our target audience for GeoBarista is people and institutions who will use the application internally as a tool for further development using geospatial mapping. Companies that would benefit from the application are looking for ways to streamline and simplify the way in which they organize and group images and image metadata. An example of a potential user would be a firm that contracts with government agencies for the purpose of mission planning and intelligence. Next, I'd like to talk to you about some of our main features. The main features of the application relate to image and image metadata sorting and mapping. Specifically, these features include loading and plotting image footprints and their respective thumbnails on a map, filtering and sorting the loaded images by their various metadata fields, selecting images within a specific boundary by setting the bounds with points or drawing an area polygon on the map, manipulating files on disk by copying, moving, or deleting selected images, files, or image file groups. And finally, one of the features I'd like to talk to you about is the ability to plot image footprints and thumbnails on the map. So as images are loaded into the application from disk, they are plotted onto the map. The visible display is a thumbnail representation of the full image overlaid where it exists on the map. The bounds of the image footprint is outlined by a border which changes color based on the selection or deselection of the individual images or user-defined image groups. The visibility of the footprint polygon can be toggled on or off to reveal only the thumbnail. Conversely, the thumbnail can be toggled on or off to reveal only the footprint polygon.
Sorting is done by simply clicking on the Sort Images button next to every column header. Only one column can be used to sort at a time, with the exception of the Selected Images column. Sorting by the Selected Images column takes precedent over all other sorting options. Filtering is done by clicking on the Filter button on the image table. Once clicked, this will open the Filter menu with a variety of filter options. The values in these options are based on the images already loaded, such that if you filter by mission, you will only be able to filter by missions currently loaded into the application. Furthermore, when you set one or more filter option and hit the Submit button, the image table is then updated to only display images that match the filter options. There are two main ways to select images within our application, through the image table and on the map. On the image table, selecting images here is done by checking the corresponding checkbox or the Select All checkbox. On the map, to select an image, you can simply left-click on the map for a point selection or by using the draw selection tools. With the point selection, the application will select all images whose area is within the clicked point. With the selection tools, there are two tool options, Draw Rectangle and Draw Polygon. Both function in a similar way. Once the tool is selected, you can then mark an area on the map, and any image that intersects that area is then selected. There are three main steps to the file manipulation process. The first step is getting a list of the selected files. This is achieved by querying our image table for all the selected images for their base names. Using the base names from the previous query, we then query our file table for all the files that share the same base name for their full file paths. The full file paths are then passed to the file manipulation menu. The second step is allowing the user to set the options for the file manipulation, such as what extensions to include and what actions they wish to perform. The third step is to perform the file manipulation. Once the Perform Action button is pressed, the application creates a list of files to perform the action on, such as only the JPEG files if only the JPEG checkbox was clicked. The application then performs the selected action on these files.
All right. So, additional features. The lat long box is, a minor addition that we made. You can see it down at the bottom left here. Gives you your zoom level, your latitude and longitude, gives you a general idea of where your screen is centered on the globe. It's not huge, but definitely, it's there. The bigger thing is the plugin command line tools. And the idea is that a user is capable of supplying a command line command with a list of arguments, however you would use it on the command line, to run certain operations. For example, in the image, you can see the thumbnails are generated using GDAL translate, and that's just a command and can be subbed out for anything else. So if you have your own like software, or maybe a company uses something proprietary, you can always make a command to that to generate thumbnails with a different software that does something more attuned to what it is you're looking for. And the other thing is the external viewer, which basically is to allow you to open up your set of images that you've generated or are working with or have selected in some kind of external thing for other manipulation. So something like Photoshop or, what have you. All right, future works. So first, performance updates. The program tends to slow to a crawl during the use of large data sets. Once you've hit like thousands of images, tends to get very slow. So performance updates are pretty necessary to be able to run those moving forward. Selecting images by Flightline was actually a request from someone at Parsons about being able to distinguish flights that, when a plane goes over a certain area and they have to turn around, they have different flight lines as they stop taking pictures so that they can get turned around and take more pictures, either planes or drones or whatever is taking the images, and being able to distinguish between those lines as the plane or whatever is making its turnaround. Although we didn't quite have time to finish that request, it'd be great to get it done in the future. And more filter options. So metadata comes in all shapes and sizes, not just the files that we support. So being able to extract data entries from those files and actually be able to sort through them would obviously be a benefit to anyone who's using the program, because currently we only support generally PPJ, CSV files, and maybe one or two others. But it's very limited given, metadata can come in all kinds of formats.
Hi, my name is Tim, and I'm going to be speaking to you a little bit about the architecture of GeoBarista. GeoBarista's architecture is a fairly typical one for modern multi-platform web apps. The core of this app is essentially a read, process, store, display process, which is implemented using the MERN paradigm, MERN. So we're using React.js to display graphics and perform user interaction, Mongoose and MongoDB to store and retrieve formatted data, Express.js to communicate between Mongoose and React, and Node.js to tie the whole thing together. This kind of slightly complex architecture may seem unnecessary for such a simple app, but the main real point of this is so that this could potentially scale up into an actual hosted web app fairly easily. And to wrap everything up, we're using Electron, which is a framework for running these types of modern web apps as a desktop app. In addition, it gives you additional permissions into the file system, which we need in order to basically scan an entire folder of files and cross-reference them. And this is very heavily used by large software installs or have software with large install bases. That it's a very proven technology. So on the back end, the NoSQL architecture is a bit different to design than your traditional RDBMS systems, but there are very good. There are a lot of really nice upsides to this, from less code having to be written for boilerplate to performance increases. So this is a traditional RDBMS design for what our system looks like, and as you can see, we're specifying the cardinalities, foreign keys, all that good stuff. Everything's split up into these entities. But this is what our backend NoSQL DB looks like, and you see it's much simpler. It's dramatically simpler. And the reason for this is you just simply have tools that allow you to nest items within data structures that you don't have within traditional RDBMSs. So it really gives you a lot more flexibility and power and the ability to expand it without having to redesign the whole database, which is really nice.
Hi, so today I'm going to talk about the technologies we use for the front end. Firstly, we was building an initial prototype by using HTML, CSS, and JavaScript, but later we realized using React will give us more advantage. So we start everything over again. React helps us to modularize the components. It is easy to maintain. React has the logical design and the components are reusable. For the design for the front end, we use Material UI. It works nicely with React. Everything is configurable and predictable. By using Material UI only, you have a uniform style in our design, and it also provides rebuild components with different options. Material UI also provide a variety of icons. This is the main display for our app. So React helps us to split everything into components. Like the left side right here, we have a map class. Inside the map class, we have smaller class like overlays or like drawing tool. In the right side, we have like image table menu class. Inside the image menu, we have like toolbar class, table header class, and table row class. Every icon you see in the toolbar right here is provided from Material UI. Material UI also provides different kind of dialogues. In this example, this is the filter dialog box. So we just adding the components we need. Like in this case, the drop down list, and it also provide buttons with different options for color. Here's another example of the dialog box provided from Material UI. As you can see, Material UI provide almost everything we need, and then the developers just need to focus on implementing the function to work with the back end. Another technology we use in the front end is Leaflet. Leaflet is a JavaScript library. It provides friendly interactive maps. It's also very simple to use, having great performance and great usability. It provides almost every need options for this project, like zooming, map layers, mouse interactions, and overlays for the thumbnail. Another technology we use is Electron. It helps building cross-platform desktop apps from the web app. So the hard part for building desktop app become easy. Electron cover every need for this option, like native menus, notifications, as well as window installers. Here's some options provided by Leaflet, like the drawing tool. In this project, we use a polygon and the rectangle. So all the image inside the drawing will be transformed into GeoJSON data to work with the back end.
Now for our development process. Our Capstone project is split into two back-to-back quarters. During the first quarter, we set up the teams, we were assigned our projects, and the team spent most of the term understanding the requirements that we were given by our sponsor. We spent the time making major design decisions and handling prototype work. Some of these prototypes were simple, but were used as a way to see how we could include certain functionality into the final product. One example of this was to figure out how to display thumbnails on the map, and we found during our prototyping phase that we needed to use certain third-party libraries. In the second quarter, we started short one-week sprints. We would meet every Monday to discuss the last sprint and pull tasks from our backlog. This is also when we would assign tasks to team members, depending on their areas of expertise and the time that they had available. To make development easy, we use Jira and Bitbucket. These tools integrate together easily, allowing tasks to naturally flow from different states such as open, to in progress, under review, to finally being finished and approved. Every team member had significant contributions to the project. I work primarily as the product owner. I would demo the project to OG Systems every Wednesday to show them the features that we had been working on, and I would ask for feedback for the direction that they would like to see the project go. I also worked on the initial architecture setup for the MERN stack and set up the Electron build system. The rest of the team on this page primarily handled front-end work. Keep in mind that these are the major contributions, and each team member did miscellaneous work here and there, such as bug fixes. Jomar worked on the Leaflet draw tools to allow selecting images by polygon and rectangle. He also handled the front end and back end of the file manipulation window and set up the sorting of the image table. Khoi worked on the filter dialog menu and set up how it interacts with the back end. He also did the work to display thumbnails on the map, and Mike set up Leaflet to display the image boundaries, created the thumbnail dialog, and worked on the front end of the time interval feature. This next slide covers those on the backend team. Tim worked on the design of our database and set it up using MongoDB. He also did some optimization to speed up communication between the front end and back end and worked on the time interval feature. Shayan did most of our utility classes to parse metadata from CSV and PPJ files to be displayed on the front end. Part of this work was projecting coordinates to a format that Leaflet can use. Trevor worked on the options menu, both front end and back end. This included how the back end uses external tools such as GDAL Translate to convert images to JPEGs for the map thumbnails.
Right, so unexpected events. Aside from the coronavirus pandemic, which I'm sure everyone's had to deal with in one way or another, we actually had to start over in the start of spring term because we had some architecture issues and we needed to kind of rebase everything to be able to lay the groundwork to actually progress the project. And so we basically started completely over then, but generally everyone did a good job doing that kind of 180 and kind of laying the groundwork. Jacob got it set up pretty well, and everyone made a nice pivot, and we were able to recover and get the project done. Okay, customer feedback. So first off, thanks to Parsons for sticking with us the entire way and giving us feedback as we gave them the progress that we had made throughout the term. And yeah, we delivered more than the minimum viable product that they had asked for, although it's not quite in a state to be deployed because it was originally intended to be sort of a proof of concept because the project as a whole is very, very large and maybe not entirely within the scope of our the time that we got. But nonetheless, they seem to be pretty happy with it. They extended an internship to someone on the team to continue working on the project over the summer. So it seems that they were happy enough with the product that they were willing to, hire someone to keep it going. And it seems that, we got what they asked for, plus a little more complete. And looking forward, things are pretty nice. Okay, so lessons learned. Definitely learned a lesson about spending time designing architecture, making those decisions, because we did have to start over partway through the term and kind of looking at laying the groundwork for the project in such a way that it is going to be able to reach the point that you want it to. Obviously, learning experience, we pivoted, we recovered, but it's good to keep in mind. And some of the features that we actually were planning on adding ended up being much more complex than initially we had thought. And this is, it's inevitable. It's kind of a little trap, right, that one can easily walk into. So you think something's going to take 1 or 2 days, it ends up taking much longer. So best to kind of plan ahead for that, give yourself time. Emergencies happen. And we also got that request that I was talking about earlier for the flight lines. And, it's important to kind of stop and say, all right, well, this is a feature that was requested, but it's not part of the minimum product that we're trying to, ensure is finished by the time we reach our deadline. So, it's important to stop and say, all right, well, we can try, but unfortunately, we might not have the time to actually get that finished. But, such things are inevitable. And we have to finish the agreed upon requirements before we can focus on anything else.